Hello, this is the last video of week 1. In this video we look at hashing and hash functions. First we define the concept of a hash as a mathematical function. We show some examples of hashes, not all mathematical. What we need to secure the blockchain are cryptographically secure hashes. We define those and look at some examples. Next we look at the concept of a collision in relation to hashing. Collision resistance is what we need from the crypto hash. We briefly look at the randomness of the crypto hashes. And we also look at some probabilistic properties of hashes. The hash function has 3 major properties we are interested in. The input can be any string of bits as long as it terminates. There is no size limit. The output is of a fixed size. The output is always a defined number of bits for a specific hash function. And it's sufficient to compute. The time to compute varies linearly with the size of the input. So if we input a string twice as long, computing the hash takes about twice as long. A hash can be seen as a fingerprint or digest of the input. If we see this as the input space, and this as the output space, which usually is smaller, we can see the hash as mapping a point in the input space to a point in the output space. This is the hash function mapping a point in the input to a point in the output. For example, the first letter of a name can be the hash, or the modulo function is a hash for numbers. The nearest postal code could be a hash for locations in inhabited areas. For example, for the hash modulo 3, what we show here is the hashes for 5, 13 and 20 being 2, 1 and 2. Cryptographically secure hashes have 3 additional properties. These are collision resistance, hiding and puzzle friendliness. We will only examine the collision resistance at this time. Here we show some well-known crypto hashes. When you download a large file from a website, you sometimes are shown a hash on the website. Once you have downloaded the file, you can check its correctness by computing the hash on your PC. If the hashes are the same, you have the same file as on the server with a very high probability. A question you may answer in the comments: why is this true? 2 different inputs can hash to the same output. This is called a collision. For example, if we use the hash of the first letter of a name, we see that Mark and Mike will both hash to the letter M. Using modulo 3 as the example hash, we see that 13, 4 and 19 all hash to 1. Crypto hashes have a property we call collision resistance. This means it is virtually impossible, or as it says here, infeasible, to find 2 inputs that will hash to the same output. Again, this is the input space and this is the output space of the hash function. And if we have one input x1 and its corresponding output h of x1, now it's not possible in a reasonable amount of time to find an x2 that maps to the same point in the output space. So finding this point called x2 that will map to the exact same point is very difficult and will take an enormous amount of time. The result of a crypto hash appears to be a random collection of bits. 2 similar inputs will give very different outputs. Changing a single bit in the input might change more than half or even almost all bits in the output. Examining large sets of outputs of crypto hashes should show random behavior in the outputs. Let's examine some probabilities related to crypto hashes, which we will use later in the series. The probability that the first bit of the hash is 0 is exactly 1/2, because it can have 2 values, and we have stated the result of the hash behaves randomly. As a consequence, the probability that the first 2 bits are 0 is 1/4, and that the first 3 bits are 0 is 1/8. In general, we can find the probability that the first n bits are 0 as 1 divided by 2 to the power n. For 10 0 bits, this means 1 divided by 2 to the power 10, or 1 divided by 1024. So the probability that the first 10 bits are 0 is almost 1 in every 1,000. This is the conclusion of week 1. In lecture 1, we looked at some general introductions. In the second lecture, we looked at the blockchain as a chain of blocks. Lecture 3 was about the distributed network. Lecture 4 looked at the consensus model. And this lecture, we looked at hashing in more detail. This concludes week 1 of this lecture series. I hope you enjoyed it. Please let me know in the comments or in an email. The next week of the lecture series will focus on the blockchain implementation under Bitcoin in more detail. As always, for questions or suggestions, please contact me on the email address shown. Thanks.